各位现场。Ladies and gentlemen, welcome to the forum today. I'm Rebecca. Countries around the world are actively promoting the development of net zero emissions and renewable energy. Leading manufacturers in various industries have successfully asked their suppliers to reduce carbon emissions. Taiwan is an important player in the global supply chain, and all sectors must work together to achieve the goals of energy transition and net zero transition. Therefore, this forum focuses on energy storage applications in business and green energy business, covering topics such as demand response, V2G, energy management, green power purchase and sale, and so on, with the hope of introducing industrial practices, analyzing market opportunities, and guiding practices to strengthen industry's willingness and consensus to support energy transition and actively implement low-carbon actions to further enhance Taiwan's net zero competitiveness.
还有工业局以及绿能科技产业推动中心以及三米能源产业部来主办。同时，我们要特别感谢我们的协办单位中华民国对外贸易发展协会以及金属工业研究发展中心，一同让我们今天的论坛呢更加的完善。 So today's event is advised by Ministry of Economic Affairs, organized by Bureau of Energy (MOEA) and Industrial Development Bureau (MOEA), also Green Energy Industry Promotion Center and Semi Energy Group. And we could not have made this event happen without our co-organizer, Taiwan External Trade Development Council and Metal Industries Research and Development Center. Thank you for your great support. 让我们今天的
And before the start of the event, please allow me to briefly, may I invite the Ms. Joanne Su, Senior Director of SEMI. It's a pity that actually Deputy Minister Zeng is in the Legislative Yuan now. So I want to thank the Deputy Minister Zeng and Legislator Hong, and then Deputy Director Zhang Jian from E3, and also Director Huang from BSMI, and also Mr. Paul Lee from Delta. Ladies and gentlemen, good afternoon. Welcome to the Energy Taiwan and the Green Energy Lead to Net Zero Era Forum advised by MOEA, organized by Bureau of Energy, IDB, GEIPC, MIRDC, and the Semi Energy Group. We can see that in line with the international trend of net zero, 137 countries around the world have declared net zero emission targets, and many international manufacturers have also begun to accelerate their pace in response to the market expectations for environmental sustainability, and thus require supply chains cooperation to promote green energy and carbon reduction. Net zero transition is no longer just an environmental issue, but an economic issue for the international competitiveness of the industry. It's really important to be able to uphold net zero and energy transition. Otherwise, we'll be not able to compete internationally. And Taiwan is an important part of the supply chain. In order to achieve net zero, we must make arrangements in advance. We have to shoulder our share of responsibility. Otherwise, we will lose out to international competitors. And in March this year, the National Development Council proposed Taiwan's 2050 net zero emission path and strategy. which reveals Taiwan's strategy and determination to promote 2050 net zero transition. To achieve this ambitious goal, renewable energy and green energy technology are important starting points and also keys. According to the net zero carbon emission path plan, the proportion of renewable energy will reach 60 to 70% in 2050. In addition to accelerating the construction of solar energy and wind energy, it is necessary to continuously improve the power generation efficiency and expand expansions of innovative energy, including other types of different sources. We can see we need to create more options of innovative energy, including hydrogen-derived ammonia co-firing, small hydropower, and biomass energy. It's important to accelerate their commercialization in response to the intermittent issue of renewable energy. And then today we'll hear from a lot of experts talking about how to develop energy storage system, so that we will be able to have more stable supply of green energy. So actually, SEMI is encouraging enterprises to purchase green energy so that we can help Taiwan to proceed to energy transition. We're facing a lot of challenges, but if we don't do it today, we will regret tomorrow, because it's important to maintain our international competitiveness. SEMI Energy Group is very honored to be able to participate in the historical moment of Taiwan's green energy transition with the government and the industry to jointly create Taiwan's low carbon and net zero era. And then for the past 16 years, people have been asking me how come SEMI, started to engage in the energy industry. We know that SEMI focused on the semiconductor industry since its founding, and then we have a PV, committee, and then we realized the importance of the energy industry. So we are working with the government and the industries, and we also want to work with the government and the industry to help promote the government's industry. So we can see, so for the SEMI Energy Group, we are actually venture into different industries, and we have more than 100 members. So we are providing the most comprehensive platform. So in order to move toward energy transition, we actually set up a semiconductor sustainability committee, so that we know that the semiconductor industry is an industry that requires a lot of green energy. So it's important that we engage in this industry, and then we need to help formulate the green supply chain in Taiwan. And here we will be listening to many experts in the industry, and we'll be able to promote our ideas, because we have to think ahead for what will be needed in 30 years. So I think it requires collective efforts for us to move toward to our common goal. And I want to thank all the participants. I want to thank Energy Taiwan to promote net zero transformation and make Taiwan a more competitive green energy and net zero center in the Asia Pacific, and then take action for the next generation of environmental protection. Thank you very much. Well, thank you, Joanne, for your opening remarks. And then also, now let's welcome legislator Hong Shen Han to say a few words. Senior Director Su, experts from the industry. I've seen many familiar faces here, because these are all industry experts who I consulted with before. So I'm honored to be able to come to the Green Energy Lead to Net Zero Era Forum organized by SEMI Energy Group, as well as GEIPC and MIRDC. So I'm really here to learn. So I always come to the Energy Taiwan exhibition every year. So here we will be able to learn about the latest trends. But I think this year is a very special one because in March, like what Joanne said, the National Development Council announced the 2050 net zero pathway. And then this is a framework, but actually there are several meanings, several layers of meanings to that framework. Because in the past, the Taiwanese government has never formulated any policy, with a time span of 30 years. And the National Development Council believed that it is necessary to do so this time. Many times when we identify the problem for now, it's too late to address the problem because it's actually an accumulation of what's went wrong for the past 10 or 20 years. So we really have to think ahead about what will happen in the next 3 decades, what we don't want to see in the future. So that means we have to, starting from now, what are we supposed to do? What kind of actions do we need to take to prevent that kind of problem from happening? So I think for the past few months, and I believe that, for the 12 strategies, all government agencies are, making plans to reach our goal. So I know that there are a lot of experts here giving talks later. Just when President Tsai Ing-wen took office, people started to talk about all kinds of renewable energy sources. Really now we are at the stage of utilizing smart energy. So today we'll be talking about the applications of smart energy like grid, energy storage, E2G, and HEMS. And then we can see that, now we know that there is an election coming up. I'm not here to ask you to vote for me, but we know that during the election year, we are consulted to provide suggestions for the candidates, and we know that for like people in southern Taiwan, they will be asking, we have installed, for example, solar panels, and what's next? And what's next is the utilization of smart energy management. And also we will need more talents in smart energy management, so that we really need this kind of talent to be able to bring more opportunities for different districts in Taiwan. So maybe after the election in November, I believe that many cities in Taiwan will need to, reevaluate the energy-related policy. So today we talk a lot about, for example, EV and HEMS and V2G, and I think this will bring about a lot of new opportunities. So that's why this forum is very significant. And also, I have to admit that if we look at the energy-related policies in Taiwan, the government has amended many energy-related policies, but the government's focus is on the liberalization of green energy. But when it comes to energy storage or energy dispatch, I've been talking with my colleagues in terms of regulations, rules and regulations. There's still some room for improvement and amendment. We know there's a regulation for major energy users, but in the past, the government required the energy users to procure more green energy. But we know that now the pressure doesn't come from the government anymore, but from their clients. So what we want the major energy users to do is to fulfill their responsibility in, for example, energy storage. So, what we're facing is different from what people are facing in 2019. But that means that we need to, for example, amend our electricity law to respond to the current trends. And also, it's important to focus on data utilization and data governance. But this part is still lacking in our current rules and regulations. So I'm here to learn from all the experts, but at the same time, I will be visiting you, very frequently, in relation to the future amendments of different rules and regulations related to energy. Because we have to make these kind of amendments to provide a good environment for the private sector. So you will see me for sure in the future. Thank you. Well, thank you, Legislator Hong. Thank you for paying so much attention to green energy. Now the next speaker is the Deputy Minister Zeng from MOEA. He has recorded a video to share his opening remarks with you. The organizer of Forum SME Energy Group, distinguished guests, ladies and gentlemen, good afternoon. It's a great honor to be invited to participate in the Green Energy Lead to Net Zero Era Forum. Due to the official schedule, I can only greet you via video. At noon of August 22nd this year, Taiwan's solar PV installations of power generation reached 5.55 gigawatts, accounting for about 15% of the current load, nearly twice the total power generation of nuclear power plants at that time. Since 2012, the MOEA has cooperated with different local governments to promote green energy deployment at full speed. The solar PV installation had grown from 942 megawatt in May of 2016 to 8.9 gigawatt at the end of August this year, an increase of 840%, and 2.5 gigawatt of new installations this year, which is the highest annual installation volume ever recorded in a single year. By the end of this year, the number of offshore wind turbines will reach the milestone of about 200, and we can see that the fruit of energy transition are gradually booming everywhere. With the massive growth of PV and wind power, there will be many new business opportunities in the future in the combination of power dispatching and green power supply and demand matching. In order to enable our industry to seize this wave of opportunities, we'll continue to seek new markets to help the industries to go abroad and play the international cup. But expanding green energy installation must take place with energy storage to improve the stability of power generation. The MOEA promotes energy in 3 stages, starting from a demonstration project of energy storage of 7 megawatt. This will gradually open an ancillary service market. In 2020, Taipower opened the bidding of the auto frequency control auxiliary service procurement. 5 manufacturers won the bid with a total capacity of 15 megawatt. Last year, a power trading platform was also launched to introduce private power resources into the power market. Now, the total registered trading capacity has reached 321 megawatt. I'm also very happy to see there are many topics such as mobile energy storage and V2G in the forum today. In addition to the introduction of the V2G business model, the MOEA also reviewed the changes in the EV market, reviewed the number of charging piles which have been built, and formulated national standards for the safety of charging piles. Another topic today is about green energy business, which is also where the future lies. With the increase in demand, new business models for purchasing and selling electricity will inevitably appear. For enterprises, green electricity is an important production factor in response to the RE100 supply chain carbon reduction and electricity consumption clauses, as well as the needs of environmental impact assessment for plant construction, and is one of the best practices for companies to demonstrate their social responsibility. In the future, the industry demand for green electricity will increase, and the government will make efforts to allow large companies and SMEs to have the opportunity to purchase green energy. Large companies can trade green electricity with developers through CVBA, and SMEs can purchase green electricity through green electricity trading platform. And then with the zonal development in the third stage of wind power, it can be expected that the green electricity trading market will become more and more prosperous. And OEA will strive to open up the market so that companies can bring their own technology, that bring the energy to grasp green business opportunities to increase their competitiveness and accelerate the transition. I'd like to wish to this forum a complete success, and the industry can achieve low carbon and sustainable development. I wish you all the best. Thank you. Well, thank you, Deputy Minister Zheng. And also we have invited many guests here, so we'd like to invite them to come to the stage for a group photo. And now, first, let's welcome Mr. Yan Yangchen, Vice President of Impact Office, Gogoro.
Sammy 苏正平 of Sammy。接着我们欢迎联齐科技严哲渊创办人及执行长 Mr. 哲渊严 ，the founder and CEO of NextDrive。紧接着欢迎企儿行绿能林君颖副总经理 Mr. 君颖林 ，Vice President of eTreeGo。接着欢迎工研院绿能所张简乐仁副所长 Mr. 乐仁张简 ，the Deputy General Director of Green Energy and Environment Research Laboratories at eTree。接着欢迎上尾新能源林庸尧董事长。I'd like to welcome Mr. Lucas Lin, the Chairman of Swancord Renewable Energy。紧接着欢迎台达电能源系统解决方案事业处资深处长及三里智慧储能委员会主席艾祖华博士。Welcome Dr. Paul Ai, the Senior Director of Smart Energy Solution Business Department at Delta and Chairman of Semi-Energy Storage Committee。接着欢迎经济部标准检验局第6组组长暨国家再生能源评鉴中心主任黄志文先生。Mr. 志文黄 the Director of Division 6 BSMI MOEA and Director at T-REC Center。紧接着欢迎立法委员洪申汉先生。Would like to welcome Legislator 申汉洪。好的，我们请舞台上的贵宾可以帮我们看一下正中央的是举手的摄影师。我们先看前方的中间摄影师，来3、2、1，那也麻烦大家帮我们比个赞好吗？来为我们今天的这个论坛开启一个这个永续的开端。好，谢谢，我们感谢舞台上的贵宾，也可以麻烦请先回座。那我们在今天论坛当中呢，会将深度探讨永续发展带给企业以及我们全人类的生活变化和创新。那我们今天也聚焦2大主。
So today we'll focus on the two themes, green energy storage and also the business of green energy. So first of all, we have the first speaker, Deputy General Director of Green Energy and Environment Research of the Laboratories, eTree. He assumed the role in 2022, started leading the team to enhance green energy and power electronics innovation technologies and application to strengthen cooperation between industry universities in Taiwan. His topic is breakthrough innovation of energy management. Distinguished guests, ladies and gentlemen, and all the experts, good afternoon. I'm here on behalf of the Green Energy Institute of eTree. I will talk about the breakthrough of innovation of energy management, the solution of a demand response. So first of all, I'd like to share with you a few concepts for the green energy industry. Actually came about because of climate change. And as we understand, the power supply and the demand has completely changed because the trend is carbon reduction. Therefore, power generation also needs to come from renewable energy. However, there is a very distinctive characteristic of a renewable energy. It's not as reliable. It's not as reliable as traditional energy. Therefore, power consumption may need to also depend on the variation of the renewable energy. And so we need to use electricity more in a more smart way. Okay, let me show you. So in the outline, I will talk about demand response. And we'll talk about the trend of DR in the world, and then what is the current status in Taiwan, and also I'll talk about VPP, virtual power plant. And then when we create VPP, what technology can do for us, and then is a summary. So what is demand response? Demand response means when the power supply is under stress, for example, when there's not enough reserve, and then demand response encourages users to reduce their consumption and then to stabilize the supply and demand. So that means we need to cut down consumption. Well, it's not necessarily the case. There's more we can do with that. Being a user, having demand response is actually very beneficial to the entire system. For example, if the consumption, like you see on the chart to the left, so before dispatch is very high, and if I could reduce it, then it could actually be cut to the level on the right. So that means we can have more stability in the power supply. So for demand response, it doesn't just mean energy saving. Actually, from what we see here, the curve could be the one above. So if we can actually save energy, if we can use more energy efficient appliances, then we can actually cut it down to the dotted lines. So for these dotted lines, what can we do? So during the peak hours, we can actually reduce the power consumption. So for that, we can reduce the peak. So it doesn't mean that you need to sacrifice, but actually you can reschedule your workload. For example, you can plan your workload so that you can use electricity more smartly. So we will be able to decrease the consumption at peak value. So for the demand side management, this is actually very fundamental. And on top of the pyramid, we can also have a demand response. So you don't have to cut back for a long period of time. However, for the most important period, for the peak period, if you cut back your use a little bit, it can help us go more smoothly. So this is not something that we invented. This has been in practice in Western countries, especially in California. So for all the household users and commercial users, they all adopt this program so that for example, they use air conditioning for heat, and also for cooling is actually the one that consumes the most power. So if you could just install the smart thermostat, you can actually save a lot of power. So this is from SCE, and it's from one of their studies in California. This is from 12 a.m. to 11 a.m. And so there is actually a large consumption. However, due to the congestion of power supply at a particular moment, they like to notify the users about demand response. And at 2 to 3 p.m., they also implement a demand response. So you could see that the green line dropped, the green curve dropped. So that is a gap, and then so that would continue until 7:30. So what did they do? So this is what the users are able to achieve. They can actually reduce their power consumption to stabilize the supply. So for demand response, this is just the beginning. So you don't. It's not just about turning down the air conditioner. Actually, in France, in Italy, the Netherlands, and the U.S., and they have a vehicle to grid, V2G. So in the future, when we have more EVs, they can actually put power supply on the grid. And also in the UK, they start doing energy smart appliances. So other than the air conditioning that can respond to DR, there are actually more appliances that can adopt the same. And then there are also other things that can help to stabilize the grid, and they can actually be aggregated. These are the VPPs, virtual power plant. And so they can, for example, in Australia in 2021, and they had 31 megawatt VPP. For example, Tesla also contributed to VPP. They're also participants on VPP. And then in Chile, they're also developing VPP by STEM Inc. I'll tell you more about VPP. So the users can actually provide support. For example, in 2020, it's just about 2 to 3%. However, given a small percentage, but it actually translates into a very large number of powers saved. And then for energy response, for demand response, they can actually also be expanded. In Western countries' experience, and you can see that in buildings, for example, in the light blue block, and also transportation, and then hydrogen production. You can see that hydrogen production and EV, and they will be the main source of DR, and they have huge potentials. If we look at the examples in Taiwan, and how do we encourage users to save power? Taipower has actually been offering incentives based on prices. For example, as we understand, there is the tariff for summertime. Well, because in summertime, the fee is higher, and so that you need to save more energy, you need to consume less. And for the users, if we want to encourage them to cut back use at a certain time frame, and we will offer incentives. So demand response is a way to provide such service. And we can see that demand response is basically price driven. So how do we go from the dotted line to the line to the curve above, or how do we go between the two? Actually, demand response increases every year, and we can see very stable growth of demand response, which means we do have the potential. But the question is about how do we develop or increase that potential. So in this slide, basically, we see a lot of non-wire alternatives. By non-wire alternatives, we mean for the users, you don't need to expand anything on the transmission and distribution. So for the users, very little investment on their side. To give you one example, being a user, say for example, if you save 1 unit of electricity, you save 1 unit, and from the generation side, and for example, there's actually loss in the transmission about a 0.2 unit. So basically, for the users, it's very efficient if they are actually saving power consumption on their side. And so for the generation set, they will be able to save more. Say, for example, if the users there are paying 7.2 to 7.8 NT per unit, and if they are cutting back on their consumption, so that is actually a lot of power saved. So when the cost reaches 7.6, and we can notify the users, this is actually the fee is actually getting more expensive. They can start reducing their consumption. So we could see that there is actually huge cost benefit, because in the past we only look at the cost of fuel. However, for the generation set, in order to produce power and also transmit and distribute that to the user side, and those costs would actually not included. So for the users, they can actually simply do that. And so now we have installed ACs in all classrooms in school. People may think that it would suck up a lot of power. However, how do we mitigate the power consumption so that it becomes very so that it becomes a very environmentally friendly policy? So what do? We have the EMS energy management system, which gives us the information about the power consumption of all the air conditioning. And other than that, if the power supply is tightened, so we don't necessarily need to switch off the AC. However, we can set the temperature a little bit higher, and so that we don't need to use as much power. So we have these kind of measures in place to allow the students to continue to use air conditioner. Okay, there's a lot of ancillary service that can stabilize the power consumption. I'm sure you're all familiar. And I know some of them do frequency regulation, and some can do spinning reserve or non-spinning reserve. So there's actually much that we can do, demand response. And we can actually, there's much we can do. For example, now we have people that are doing frequency regulation, and then we can also participate in spinning and non-spinning reserve. And they all come with a price. This is actually a very good incentive for the user to participate in the DR program. So in the past, we only think of the air conditioner as the appliance that's suitable, and then the energy storage system, and it can actually charge and also discharge. So when there is limited power supply, it can actually discharge. So when, for example, when the renewable energy is over-generated, it can actually be stored and then discharged later on. And then there's also the household users. I will talk about them in a little bit. So for all the users, they do not just have one single resource. They also have power generation, and they also have PV or small wind farm, and also maybe household storage system. So all these facilities can actually be integrated so that they can be used as one single source for dispatch. At A-Tree, we set up a platform for demonstration. Because we have many different energy storage system, and there is the fuel cells or different type of cells. And in terms of the load, it can actually be used for lighting and also water cooling machines, and also the diesel motor. So for all these equipment, and they can also be aggregated. And we do not just have the site in Hsinchu. We also have our branches in central and also in southern Taiwan for all these different campuses, and they are actually this spread across Taiwan, so that we can actually bring together all the resources from different A-Tree branches, so that they can be dispatched later. And so there's we can actually function as a power plant. So this is the field trial for spinning reserve that runs from 8 a.m. to perhaps night to 10 a.m. For the orange part, this is the energy storage system, and the purple part is the solar site in Tainan. And then for the blue part, it's the PV system, and then the green part also PV. In the morning, so from 8 o'clock when the sun rises, and we see there's more power generated by solar energy. So if there's an output of 1,000 kilowatts, the rest of the power is actually, well, if it's not enough to power to supply for the peak hour, we can actually use power from the storage system that is from Tainan. And so you can see that these facilities, they spread across Taiwan, but we are able to integrate them. Say, for example, if the power company needs 1,000 kilowatt, So the red dotted line represents the demand. And then we can actually supply for more than 1,000 kilowatt. And then if the curve is like as indicated on the chart, so I can see from the left hand side, the our power generation actually follows the red curve, and then the deep blue curve actually follows the demand. And so the energy storage system went from discharge to charge, to go from discharge to charging, so that we can store the excess of power in the system. And for the rest of the time, because there's less consumption, so that more power can actually go into the storage system. The storage system is a very good way to regulate the power supply. And when we aggregate all the resources, it's very important we have communication through ICT with the storage system. It needs to know what kind of missions it should run at what particular period of time. So there's ICT communication, and at ITRI we have a U box called utility box. We actually place that in most of the appliances, say lighting, water cooling machines, etc. So basically, it can actually communicate with the dispatch center, so that they can communicate with each other. So when we do the heterogeneous energy dispatch, actually for each of the users, be it the storage system, water cooling machines, each of them has a different ways of communication or different characteristics. So we need to be able to communicate with them efficiently, and there is a learning curve. Therefore, we need to have a learning-enabled algorithm to perform that task. So machine learning comes in very handy. So if we take inventory of all of the entire system, where we can step up demand response, actually there's much that can be done by the households. Say, for example, there is a smart meter. It does not just document power consumption. There is actually B89, which can control the smart appliances. So with the Tai-Share protocol, and it can actually create smart home by talking to the different appliances. For example, if the AC is set at 26, and then it can actually, when we need to save power, it can actually be adjusted to 28 degrees. It doesn't cut it off. Whereas the solar PV, and it's about how to maximize the power supply. And then with the EV charging, and if we need to charge it, if there's a flexibility, you could actually, it will notify that you would do the charging during the hours where the tariff is low. So there is an AI cloud which will calculate that, and then will create the demand to control the appliances. So at ITRI, we have a demo site that demonstrates all these different tools. So demand response is not just about using less electricity, but to use electricity in a more smart way. And so I think demand response can be very useful for the storage system, for solar, and actually for all the smart appliances. They could all be part of demand response. Okay, thank you very much.
那谢谢张简乐仁副所长为我们所做的分享。那我在这边也介绍我们下一位的讲师呢，是艾祖华资深处长，是来自我们台达电的能源系统解决方案事业处，同时呢也是 SEMI 智慧储能委员会的主席。那艾资深处长呢，他在台达电的16年之间呢，拥有30项的专利，领域涵盖了电源、电路、照明，然后呢节能跟电力调节系统的控制等等。今天我们的艾资深处长呢，要为我们来进行的主题是储能产业的现况跟应用发展的路径 ，the current development and future perspective of energy storage application。那我们现在一起掌声欢迎艾资。
Now let's welcome him. Legislator Hong, Director Huang, ladies and gentlemen, good afternoon. So on behalf of Delta, I want to talk about the application deployment development trends of energy storage system. Okay, next slide. And this is the outline of my presentation. I'll be talking about the application, technologies, success cases, as well as ESSPF mode and AFC. And then lastly, I'll be talking about PV, ESS, and EV charging stations. Okay, next, in terms of the applications of energy storage system, it seems like I cannot advance my slides. So I've used this slide a lot, and we can see that there has a lot of changes to smart grids. So we have localized energy generation. So in terms of distribution, you need to have some backup plans. If there are any problems in feeders, you need to have energy storage system. And then the Taiwanese government is making new laws, and also in terms of buildings and factories, it's important to have energy storage system. So thus we need to have smart management. So with the trend of low carbon and green energy, grids need to be changed to smart grids. So in terms of the low carbon pathway, we can see that in Taiwan, we still focus on renewable energy smoothing and AFC frequency control. So people are asking, how come we need to regulate the frequency? We know that generators are initiated by wheels, and there's a relationship of N to S. If you change that, that means the positions of N and S are changed. So if there is any problem, then generators may go down. And also, for low frequency, transformers, there will be problems as well. And also for if there is any, unstable electricity, that will cause problems to the generators. If I'm overloaded, I may slow down, and also my generators may trip. So when you have extra renewable energy, that's also a problem. For example, southern Taiwan, many times has many sunny days. So we need to be able to store the extra energy. So we need to make sure that we provide very stable supply of energy. So for Thai power company, if there's any instability of grids, they need to turn that into stable. So for renewable energy smoothing, it requires energy shift. For example, if there's any extra energy during the day, we need to be able to restore it. And during the nighttime, when there is a peak of use, then we can discharge the energy. So in Q2, we can see there is a new demonstration project which has about 500 megawatts. And in terms of microgrids, actually we had installed a microgrids in Japan. When you have extra renewable energy, for example, if in 2050, more than 60% of energy is from renewable energy, if we can install microgrids locally, that means we'll be able to generate and store energy locally. Because if we can reduce the distance of electricity transmission, we'll be able to save a lot of electricity. Just like what happened in Germany, they had a policy called own consumption. If you use up the energy that you produce, you will get incentives from the government. Because if the government purchases from you and send the power elsewhere, the government needs to suffer from losses. So if you consume the power you generate, then the government will give you subsidies. So we can see that is a benefit brought by microgrids. So we can see Thai Power Company is making a deployment ahead of time, and we work with Thai Power to do a lot of research. We can see that there are demonstration pilot projects of microgrids in many districts of Taiwan. And energy storage is the core in this project. So we need to first form the grid, and afterwards, solar PV can be connected to the grid, and we need to be able to regulate the renewable energy and the load. So if there's extra energy, it will be stored in the storage system, so that the storage system can control how much power will be fed into the grid. So we can see the storage system is a fast responding system when it comes to power shortage. So the power storage can, suck up extra energy and also release energy when it is needed. So it requires a lot of good control technologies and talents. And then this slide is about AFC. I think you are very familiar with this. So Thai Power has a lot of bidding projects about AFC, like DREG 0.2 and 0.5. If it's 0.25, that means the dynamic regulation has a change of 0.25 hertz. Then your system has to discharge fully or charge fully. So when there is a need of power, and then this system needs to discharge the power, and also vice versa. And Thai Power is able to embed energy shift in here as well. So here, this part is about energy releasing. This is about energy absorbing. If you only use the electricity to regulate the frequency, then it's a pity. So you can put energy sheet here, so you'll be able to absorb energy during the day and release during the night. So by the end of September, we can see Taiwan needs 1 gigawatt of AFC, and then we can see there's actually 3.3 gigawatts of projects have been approved. We expect half of these projects will succeed. And for the first phase, we can see the tender proposes 15 megawatts. And then we can see among them, 19 megawatt is from Delta's energy storage system solutions. So if we can store extra solar power here, then it's a good system. In March this year, we proposed the project to the Bureau of Energy, because we see there's only sunlight during the day but not during the night. So that means that the facilities will not be utilized during the night. If we can use these facilities during the night for storage, then that means we can better utilize the facilities, because we can utilize the same feeders and the same transformers. So you can increase the PV capacity. You can install more PV panels. So you can utilize the facilities more efficiently. And the Bureau of Energy, green light this kind of application. And we talk about microgrid just now. Actually, in addition to these sites, there are actually many more here. If there's any energy crisis, or if there is a natural disaster like the earthquake, and also maybe if the feeders of the major grids have problems, in that case, we can utilize microgrids to supply power back to the main grid. We can see for if we want to supply renewable energy, we do it in a passive way. If we can strengthen the microgrids, even though when there is a failure of the main grid, we're still able to support local operation. If there is an extra energy, the microgrids can sell the extra energy to the main grid. And then every city and the county will be able to take care of its own power consumption. So now let's look at the energy storage system and the infrastructure solutions. We can see maybe at the factory, at a campus, we can have a microgrid. And also in shopping malls, maybe you can have your own energy infrastructure. And you have power generation, you have power storage. You can also install charging piles here. In terms of energy storage applications, we can see that there's, in many, power plants, they have their own energy storage system. And for Delta, we have a lot of, power storage system in offshore islands of Taiwan. Because since COVID-19 hits, we're not able to go overseas. And then so people travel to offshore islands. And when that happens, the local power supply will not be able to sustain the extra population. So there was power outage. So this is about the / applications of ESS. So we support the electricity lines, and also we maximize power fees at buildings, And also we focus on self-consumption of solar power. And next I want to talk about technologies. We can see there are many new types of batteries. We can see that these new types of batteries, when the capacity is larger, the resistance is lower, and it's more difficult to control the current balance. And it's even more difficult to, anticipate its SOE. And then Delta has made a lot of investment, and we will be launching our new generation products very soon. And there's a lot of changes in PCF because for power regulation, you have backup, you have charging and discharging. And when it comes to micro grids, and then there are stronger requirements on PCS. The times control has to be better. It also requires better control of connection and disconnection. So also for EMS, you need to manage microgrids. You need to have good communication with tap power. You need to be able to communicate with different generators. And also you need to be able to communicate with many, for example, power generators. Say in Jiayi, if you want to establish a microgrid, and then if you install the microgrids to fish ponds, if there's a problem, then that the fish will die. So you have to take that into consideration. So when you start a generator, the electricity current will increase by 10 volts. In that case, the machine may trip. So we have to be able to control the inciting current. So when it comes to microgrids, it really takes really good software and hardware to make it stable. And in terms of PV smoothing, so here you can see that when there is unstable solar power, then the power storage system is now at work. So we can change the control rate to be within 10%. So these are projects in Kaohsiung and also in Kinmen. So we control the change rate to be below 10% every minute. For our project in Kinmen, you can see the details inside. For example, the green line is the original change. So it's actually more than 20% of change. So the green line is actually 25%. When we have power storage, we release the energy. So the orange becomes green. So for the green line, it's actually within 5% of change. And for AFC, frequency regulation, so we can see the power will change according to the frequency. And SPM is more than 95%. And this is a microgrid in a university in Zhanghua. So this is about power usage in the university. So we will know the charging and discharging schedule so that we'll be able to optimize the power usage in the university. So this project can also make money for the university. And in terms of the project in Kinmen, if there's a generator which trips, and then we'll be able to bring back the power with less than 0.2 seconds. So we can bring back the system very quickly. So after we installed the project in Kingman, there was no power outage on the island anymore, because we know that, if there's a power outage in Kingman, it can be elevated onto a political issue. And then this is our project in Lanyu. And because, for example, there are different festivals in Lanyu, so we educate the local population that the connection between power and the local environment. And this is about CNI, about wastewater collection and recycling. And we taught the factory to save the use of electricity. And so you can see our offerings. We provide simulation tool, power conditioning system, battery storage system, control system, energy management system, and EPC. So this is PCS, power conditioning system, from small ones to big ones. So if you need a lot of batteries, like California, the batteries can work from 4 to 6 hours. So a PCS has to be able to accommodate so many batteries. In that case, we will have, one PCS serving many different batteries, have different level of voltage. By doing so, you can stabilize your system, because we have different voltage buses to serve different purposes. And then we will be launching this offering in the future when there is a need in Taiwan. And then we will be able to produce 5 mega in one system. And this is the battery energy storage system, BESS. And next year we will have a launch of a new product which has, better qualities in, for example, providing more flexible use. And this is about the safety issue, because people are afraid of batteries burning. So because you believe that batteries may burn down, in that case, you will provide very good protection. So when we do battery testing, we have to first make the batteries burn first, and then we can see how we can better protect or prevent batteries from burning. And this is about Delta Grid EMS, so we can work with energy storage to do trending, and for EV charging management, and also operation and maintenance. So in Taiwan, we have very good software to help facilitate the application of the management system. And this is the multi-level system safety. And then I will skip this slide in the interest of time. Now I want to talk about some success cases in Taiwan and abroad. So in Taiwan, we have our AFC projects, and also projects in offshore islands, in universities, and also in enterprises. We also have a microgrid in Japan working with Mitsubishi. So it's about, gas-fired engine. And also we have a system which has 3 sources of electricity. We can see the storage system responded the fastest, and then the solar PV is the slowest. And then we can see that by having this system in place, we can really help out the local city. So this is a case in Kingman. So actually the grid, fluctuations was very large. Here we can see that the fluctuation in Kingman is even larger than that in Taiwan. So with our energy storage system here, we're able to bring down the fluctuation. And on March 3rd this year, well, there was a Xingda power plant incident, which happened in the morning. We can see the frequency dropped, to a large extent, and our energy system sent out the electricity. So, and then actually the electricity sent out went off chart. And then when there's low frequency, that means you do not have enough energy. So in that case, we will discharge the energy back to the system, and also vice versa, so that we can stabilize power supply. And we can see our rate of successful execution amounted to 99.76%. And then in the future, EVs will account for a larger population of the vehicles on the road. So we can see, EV charging stations will be very important. And we can see, for example, like there will be a lot of EVs on the road, and then here, this is about the architecture of PVESS and EV charging stations. And let's look at the effect. We can see the power fees, the electricity bills in Europe, skyrocket because, like electricity is really expensive in Europe. So we can see European people may start to use wool or wood to make fire in order to save on the electricity bill. And this is my last slide. So we can see there are a lot of EVs in Europe. So when they arrive at a company, they will start to charge their EV. So the peak of the companies, is at 9 a.m. because, like European may drive 1 or 2 hours to arrive at their company. So as soon as they arrive, they will start charging their EVs. So in that case, at 9 a.m., we will release energy from the storage system. So we stabilize the power usage at 50 kilowatt hour. With the support of storage system and also solar system, we're able to stabilize the power supply, and then we're able to save up to 15.64% of electricity bill serving from Delta's HQs in the Netherlands. So with that, I'm closing my presentation. Well, thank you very much for your sharing.
Next, we'll talk about the development trend of a charging pile, V2G and VPP. And we'd like to welcome Vice President Junyin Lin from eTrigo. Distinguished guests, good afternoon. It is my honor to be invited to give you a talk on this particular topic at eTrigo. And we actually provide development work for electric vehicle. And so I'm going to talk about relevant issues. In the next 20 or 30 years, as we know that EV will be very popular. And however, there is much more to do so that it can become more popular. So this is what we are doing currently. So this is my presentation. I will use about 2 to 3 pages to talk about our company, and then I will also talk about the platform for electricity trading, and then I will talk about the trend for dispatching and what kind of research is actually being done. And this is something that can be a reference for the Taiwanese companies. And then for the next stage, V2G and VPP, what can we do? So first of all, I will talk about eTree Go. And I was talking to my former predecessor at eTree in 2018. And we got a assignment from eTree to develop EV. And the core members of our company, we actually work on the EV control systems, the MCU, PDU, and BMS. And actually, we were spun off from eTree in 2017. And even though we work on the charging solutions, but we also work together with many different brands on the controls modules. And I was very lucky to work with the inspection and also the trademark bureau, and so that we can integrate that into Taiwan's regulation. So we have formed an alliance with Houtai and also Shilin Electric. So Houtai is a very important company in the development of EV, and Shilin Electric, they are also very visionary. So together we work on these few important missions: the complete product line for charge piles and EMS compliant systems, and then the field and incorporating field and renewable energy. So we start with the car manufacturing, and then the operators, and also scooters. And the scooters, they mostly do battery swap, but we start seeing charging solutions these days. So when we were spun off from eTree, and we thought actually doing these EV components is actually very challenging, and we could do some off-vehicle equipment, and we tried to keep it simple, and we found that the work is actually getting more and more complicated. And originally we thought it's just charging and just distribution. It's not that difficult. However, and now, because of the energy that has to come from green sources, and the green energy is not stable, so that we also need to store the power. And we see there is many different sources of electricity. So not only do we have to consider the vehicle itself, but also the dispatch from Thai Power Company. When it comes to the trading platform, and so I said EV could be a problem in 20, 30 years' time. Well, because when the government is setting out the energy plans, there is actually a forecast saying that we should pace ourselves with the development. So we look at the moderately paced development for 2025. It is estimated that there would be 160,000 EVs, and by 2030 it will quadruple, so close to 0.7 million, and in 2040, and it would then again quadruple by 2050. There would be no more fuel cars. EV is the only option. Right now, we have about 8.1 million of the fuel cars. So if you look at that from the perspective of electricity, so usually the unit, well, the volume that the consumption is about 60 to maybe 100 unit, whereas in the future, so if it progresses as scheduled, then there will be a huge power consumption. So actually, every day we have about 750 million units of electricity being consumed, and but so if 10% of that, well, if 10% of the EV electricity can actually be dispatched, this is actually quite a large amount. So how do we direct that power back onto the grid? There has to be a platform for that. So Taipower has actually been developing a trading platform. So this is something we can consider. Maybe we could just join that platform. So with that trading platform, basically they gather the same types of, say, demand response. So if you do demand response, you cannot do AFC because this is actually quite different, because one is to cut down the use of electric power, another is to give power back to the grid. However, for EV, it can actually do both. So you can actually reduce the load, or you can also give the power back to the grid. So for the trading platform in Taiwan, it's not there yet. However, it will get there in the future. Right now, it cannot do both. So for the current trading platform, it basically only service the large-scale users. So they won't want to develop resources to aggregate all the small sources. So right now the threshold is 1 megawatt. If it's below 1 megawatt, you cannot qualify for the platform. So, and how do we expand the scope so that they can include more appliances or vehicles? All these different sources can be part of the platform. This is something they will probably need to work on in the future. So, so this is the current way of how the platform works, and I'll just talk about it briefly. So one is load management, another one is day-ahead ancillary service, another one is backup power capacity. So basically for the load management, Taipower wrote out a plan to calculate maybe 5 days of supply. And so they look at day ahead or the temporary AFC demand. So the fastest way, the fastest, they can actually do it within 1 second or 10 minutes, or the spinning reserve. And then backup power capacity market. So for that, you can actually use a reserve power. But the reserve power cannot be used for transaction. So these are the different products that Taipower offers at this moment. Just quickly, I will talk about the process. So if we want to be a part of the platform, right now we can only choose DR, demand response. So we can aggregate all the B to G, or maybe G to B or B1G. So we can actually provide the information to the integration platform for bidding. And if we win the bid, then Taipower can offer the list to the different platforms and to confirm. And 30 minutes before the implementation, all the resource they would actually need to report their status so that it can be used for dispatch. But of course, some emergencies may come up. So what do we do? So there are times when it's not fully implemented and we need to release the backup power. And how do we get enough resources to do the dispatch? And then how do we respond quickly to the demand? So this is what the distributed platform wants to do. And so that is actually a very important consideration. So I'll just use this chart to illustrate. So I talked about heterogeneous and homogeneous resources. So if for this distributed platform or the aggregator, so right now, Taipower only allow for homogeneous resources. So basically, you will have to be the same, say for example, DR. So all of them have to be DR. So user D is actually AFC, and so it cannot be integrated. So for all the different resources, there may be gap in their skills or in their techniques. So for example, they might not have EMS, and so using the most traditional way, they can actually use, they can notify each other, and then we hope that with all the EMS at all the sites, they could do the dispatch more quickly. So the trend of energy dispatching, we would like to include the small-scale resources, and we need to change the regulation and also improve the technology. And we, together with the Economic Research Institute of Taiwan, we look at how this is done in different countries. So first, we see that in the U.S., what they do is that they order 2222, and so they actually reduce the minimum capacity requirement to 100 kilowatt. So it's no longer 1 megawatt. And also it's cross-node and then heterogeneous resource aggregation, AFC and DR can actually be done together. And so this is great for B2G. And then the coordination of the different stakeholders, etc. So basically, it can aggregate all the small-scale resources. In Japan, Tohoku, electricity power, actually a lot of our POC reference Japan because this is quite similar, well, relatively speaking. Tohoku Electric Power in 2019, and they got the grant from the Ministry of Economy, Trade and Industry for the demo side of V2G. So they use the aggregation platform from Germany called Next Kraftwerk, which means the next generation power plant. And as you see that most of this all these appliances, they want to integrate all of that on the platform, so this is what the site looks like. So it aggregates the PV from the government, say. So it looks like the Taipower site in Shuling, and also they integrated the households as well, and this will be difficult to implement in Taiwan. So there are two types of V2G. There could be a V2B2G, so it can go through the power storage to feed it back to the grid. And then, so in the V2, and also tourist sites, they can actually just use the device to direct the power from EV to the grid. And in the EU countries, they also have the regulations, and they have this large initiative called IMET. There are 10 flagship programs across EU, and we see two demo sites. One is UK, another is France. And so the POC includes the business models, and so this is the trial in France called Drive. So say in commercial space, parking lots, all the charging equipment are now V2G, so that the users can actually come here to charge, and also they can receive some incentives when they charge here. So this is still ongoing, and the vehicles that participate can generate a benefit of about 20 euros a month. So a year is about 240 euros. And when we work with the Economic Research Institute of Taiwan, we discovered something interesting, and they do a little frequency regulation in addition to DR. In Taiwan, the frequency regulation is to be done just within seconds, whereas this one is not as fast, and so it could just be done within 2 seconds. It doesn't have to last for too long, so just maybe 30 seconds. So this is a completely different concept, and in order to widely distribute this system, they would just use 11 kilovolts. So it's actually a very small device and a much lower cost. So when we compare all these different trials, we can see that the V2G trials right now, there's only Chademo that is compliant. So Chademo is from Japan. So they are like a pilot project. And then another one that comes with the business model is from the UK. And so in France, they are an operator and they would install the equipment in commercial space, whereas in the UK, it's for the households. So they use this two-way charging pile. And like I said, well, this is about triple the efficiency of the previous one. So for each month, the car owners, they will get about a benefit about 60 euros. And this is a two-way charging. So basically, the vehicle is just plugged. You can actually do DR or AFC, and they could still get the benefit, and then it does not deteriorate the battery. And also, when it's actually a very slow rate to withdraw the power from the battery. So in the UK, they also use the CHAdeMO device, and it actually has very good potential. And so for I think so the next is CCS. That is the next wave. So in the future, when they include this two-way charging and discharging device in the regulation, and it will develop very quickly. And when we talked to the official in Taiwan, they said that we are also getting the V2G regulations ready. So OCPP, right now the version is 1.6, and in the future it will be very soon be 2.0, and will be a part of the ISO 15118 standard. And so basically it includes the information of the direction of power flow, and then it also supports certification. That means that certification can actually be downloaded onto the vehicle, so that when you pay, you don't actually have to take out your phone or your credit card. So basically, the automobile has a unique ID. Well, because in Europe, they do supply power cross country, so there is the issue of tariff. So carbon tax and also the tariff would actually be included in the billing. So 2 years ago, when I look at the timeline, and it will be realized in 2025, and so it is actually scheduled to be launched to be earlier than that. So international trend. Talking about international, coming back to Taiwan, we are trying to make some changes, and we've been talking to the universities and Taipower and Research Institute about how to bring together small-scale resources, so that we will first use DR to we can use DR to trade the power saved from EV on the trading platform. So after the trial period, we could actually reference the method in the US, and we can use heterogeneous resource integration, so that they can do V2G and also initiation to VR. So that is my presentation. Thank you very much.
Thank you, Mr. Lin. And then our next topic is the future of energy. How will energy technology change your daily lives? And the speaker is Zhe Yuanyan, founder and CEO of NextDrive. He used to be the general manager of Fresco Logic Taiwan, has been involved in energy management services and distributed energy for a long time. He hopes to help Taiwan and the Japan market to promote the dual transformation of energy and digital through the Internet of Things, cloud, and big data. Now let's welcome him. Ladies and gentlemen, good afternoon. I am Chen Yuanqi, the founder of Next Drive. When I got the invitation of the organizer, I was required to talk about that what will be the impact of energy transition to the public, to the households. When it comes to energy transition, we can see it brings about a lot of business opportunities. And actually, the production value can amount to 1 trillion new Taiwan dollars because energy has to do with our daily life. We can see, well, in the past, we relied on, large power plants, and then the electricity is transferred to the households. And when we turn on the TV, we'll be able to watch it. However, now we are seeing a change in the current status. I will use Japan as an example. So before I begin, I want to quickly talk about, my company. Actually, in November this year, we'll be celebrating our 9th year. I think for a startup, we are considered quite mature because, in the energy industry, it's really not the case because it takes a lot of technology and skills to be able to, really survive in this industry. And then in 2016, we entered the Japanese market and we started from energy management at the household level. So we can see actually energy transition brings a lot of impact to the households. The National Development Council announced the Taiwan's pathway of net zero by 2050. And you can see this is a percentage of electricity generated in Japan in 2030. And their goal is to have 36 to 38% of energy coming from the renewable sources. We can see in terms of power supply with this kind of target, Japan has experienced a lot of, impact. In March, this year, we can see, actually lots of disasters happen to Japan. We can see lots of typhoons cause a lot of damage in Japan. And also in March this year, there was a strong earthquake in Japan, which tripped a power plant. So they lost 600 megawatts of electricity. We can see Taiwan is just like Japan. When any electricity unit trip, like what happened in the Xingda power plant. At that time, we really need to rely on hydropower to supply electricity. But unfortunately, last year, Taiwan had a lack of water. And the same thing happened to Japan this year. So they didn't have, enough hydropower. But in Taiwan, we, had a lot of water brought by typhoons, which didn't cause much damage in Taiwan. We can see that, however, in Japan, they suffer from water shortage for these 2 years. So we know about, reserve margin. Actually, the Tokyo Power Company had a power shortage of 10% at its worst scenario. At that time, the Tokyo Power apologized to the public, saying that they couldn't supply enough electricity, so they required the population to work with them to save on power usage. So we can see this is what happened in Japan in March. So that means all the industries, companies, and people in Japan had to work with the policy in order to ride through this difficulty. Like in Taiwan, the government also provides a target of power saving. And then the government encouraged people to switch off appliances when they are not in use. So I want to talk about this slide first. How do they save on the use of energy? We can see all the business venues. Here, the AC is set at 28 degrees. And we know that in Japan, the people work closely. They follow the government's order. So if you went to the shopping mall, the temperature was set at 28 degrees. And also the fryers at 7-Eleven were shut down. And then now people love traveling to Japan now. So if you go to Big Camera, that is like that is a very big shopping mall for electricity, for electric appliances. However, if you went to Big Camera, they didn't turn on the products. And then if you want to see, you want to purchase a TV, you have to ask the clerk, the salespeople to turn it on for you to see if you like its quality or not. And for households, and then people complain about not having enough electricity. But I still think, part of the population will be willing to work with the government and save on the use of energy. However, after we know that there was an earthquake in March, and also in March, a cold front hit Japan, and the temperature dropped a lot. So it was really like a disaster in Japan. So after a major earthquake in Japan, many years ago, at that time, more than 3,000 people died, and 2,000 of them died from burning and choking. Because at that time, there were a lot of fires after that major earthquake. So after that, the Japanese government decided to go for electrification for heat offering. So in March, we know that it's spring. And theoretically, we expect to see electricity surplus during the spring. However, because of global warming, it's not the case in March this year. So we can see it was actually, the people had suffered from power shortage at that time. So we see, the government is thinking about, relaunching their nuclear power plant. So that tells us the importance of having correspondence, policies to support energy transition. And for Japan, they formulated a 50-year energy policy, and they were facing this kind of crisis. And in Taiwan, we have a 30-year plan of policy. So I really don't know whether we will encounter something like that in Japan. So we can see in Japan, the electricity market is free and open. There are more than 300 electricity sellers, and they sign contracts with households. There is a power exchange market in Japan, and we can see that at that time, during a very short time, we can see the wholesale price of electricity rose to 80 yen per kilowatt. The average price is 36 yen. So for electricity buyer, if I'm going to buy at 80 yen and sell at 36 yen, that means I will suffer from losses. Actually, 80 yen is not a historic high. In 2019, when COVID just started and the supply chain was disrupted, and then shipping prices rose a lot. At that time, we saw the price rose from 5 yen to 251 yen. So more than 300 electricity sellers went bankrupt. So during energy transition, when we introduce renewable energy to the grid, we will have to take necessary measures to prevent this kind of issue from happening. Actually, the previous speaker talked about VPP and the DR projects in another country. And there's a project in a VPP project in Japan, and we play the role of RA. So after Tokyo Protocol, they designed a 50-year plan, and they believe that with their 2050 net zero target, they want to utilize their local resources to reach their target. So they set targets, milestones by phase. First of all, they encourage people to install solar panels at rooftop. So they encourage to install PVs at the rooftop. So we can see there is also, FIT is set at 48 yen. And then also for their electronic appliances, they have a common standard. The government use subsidies and incentives, and they select 10 types of appliances. For something like EV charger, heater, and EcoCute, they selected 10 categories. And we are actually, certified among these 10 categories of products in Japan. We serve as a role of a gateway. So the government started to install rooftop panels in 2009. And then after the end of the FIT, the electricity company, stopped purchasing power from the generators. And then when the FIT period ended, at that time the electricity market started to increase. So the household started to consume the power that they generate. And then I think because people generate a lot of carbon emissions into the air, if we can reduce carbon emissions at the demand side, then we'll be able to reach our target more easily. So I think every person can play a role here. So the Japanese government talk about the zero energy house or zero emission house. So the household consume the electricity they generate. So we can see, they'll be able to consume green power that they generate. And then also they have their household energy storage system. And we know that Toyota, say that 1/3 of their cars will be EV by 2050. And we can see that, car batteries can be really hot. So they are thinking about how to use the batteries as regulators for household electricity usage. And the previous speaker talked about the collaboration between Germany and Japan in 2019. And then in 2022, we're working with METI of Japan. And then next year is the last year of the Japanese government subsidies, because after that, the market will be liberalized totally. So there is a project on the control of batteries of EVs. So if we look at this project, this is actually quite simple. We were required to collect batteries of 1 megawatt for households. Actually, household batteries, of course, need to meet some certain standards. And in Japan, the household batteries have two kinds of capacity, from 3 to 12 kilowatt hour. And we have this RS system to control the household batteries. And we just talk about V2G. We'll talk about battery to grid. The capacity is very small. And for Taiwan, if we want to connect those to the grid, it's actually a disaster, because they are not sure about the quality and the stability of the batteries. So in Japan, they use DR to deal with it. So they don't encourage battery to be discharged to the grid. But this year is different. And then if you are not, they encourage behind the meter battery to be connected to the grid. So behind the meter battery power can be connected, can be fed to the grid. So we work with Manubeni, a Japanese company. So they are selling Hyundai's Ioniq 5. So it has 53 kilowatt hours. So they don't talk about V2G. I think Taipower needs more time to be able to do that well. So they talk about V2X. The power comes back to your household. So I want to talk about the number of users in June. This person lives in Tokyo. He has a large house. and he has installed a 17 kilowatt hour of solar panel. So there are 4 people in his family. So in June, we can see normally the wife stays at home, and then at 7, the husband drives the children to school, and he comes back home at 7 p.m. And we know that the sun comes out at 5 a.m. So when people, when they're still sleeping, and then the EV is started to be charged at 5 a.m. And then the AC is on 24/7, and the power is enough because 17 kilowatt is actually a lot of power. And this person is able to, have surplus electricity. And then we have done some calculation to the power usage. So we can see that, the AC that they use is actually very energy efficient. And this household only pays 200 yen to the electricity company in June. And with the regulation of his EV, he's able to save a lot on the power usage. And then we think that this person may even make money in July and August. So this presents a new business model for the household. In the past, we were consumers, but now we can become a producer. So I can become a prosumer. I can generate the power that I will need. And also I make green energy. I have very low carbon footprint. So it's really important to manage the demand side. That is a good direction for net zero energy transition. So there are 2 resource aggregators, Eneris and Toshiba in Japan. With our gateway and energy management system, and we work with local SIs to install solar panels at households. So they're selling Hyundai Ioniq. So we are selling these regulation devices to them. And now I want to talk about Taiwan. Taiwan actually sets a more ambitious goal for 2050. And for Japan, they actually retain 20 to 22% of nuclear power by 2050. But in Taiwan, we swear to be nuclear free, and renewable energy will account for 60 to 70% of total energy. So it's even more important to manage the demand side well. So that means we need to have first, smart grids. And in smart grid, smart meters play a very important role. And in Japan, we can turn a consumer to prosumer because the smart meter works both ways. So we can use smart meters to do settlement. We can calculate and see whether this person has a surplus or a deficit. So we worked with Tide Power this year, and at the beginning of this year, we actually had an advertisement. So we can see the meters that we use in Taiwan is one way. So you can see your power usage 6 or 8 hours before. And now we want to be able to provide you with real-time data. So we wanted to attract 10,000 applicants, and then we were actually overwhelmed by the enthusiasm of the household. And then we can see that with the government's determination, I believe that we are moving toward the right direction. Okay, thank you, CEO Yan. And for the next topic, and then we will invite Director Huang, and then he will be talking about green energy market development strategy. Now let's welcome him.
好，各位
Distinguished guests, ladies and gentlemen, good afternoon. Indeed, my honor to participate in the forum about the green energy development strategy. So this is actually a very, very hot topic, especially when ESG has become a very popular topic. And there is actually a lot of focus being put on this issue. And today I would like to share with all of you some of the work that we did at the Ministry of Economic Affairs, the Bureau of Standard Metrology Inspection. So first of all, I would like to give you a quick overview of TREC, the features of TREC. So as you know that the renewable energy certificate wants to produce net zero emission. So with our effort, we've actually built alliance with EPEAT from the US, and so they actually work as a certificate for the appliances, and also LEED and CDP, and then RE100. We have formed an alliance with them. So in Taiwan, and it's a TREC, it would actually be qualify for the rest of the certificate. And also for Apple, they also require their suppliers to be certified with TREC. So not just for overseas market and in Taiwan, we also have many awards from various government agencies. They would also provide the award to the TREC certified companies. And then we also have multiple awards for people to apply to. And so if you get a chance to visit TREC's website, just go to trec.org.tw, you can actually look at the number of new issuance, and there is actually more than 1.6 million, and then the transaction is about 1.4 million. So the cumulative green electricity generation is 1 billion kilowatt hours. And so to the by the latest numbers, and we have there are more than 70 companies, and also there are natural persons who sell these green energy. And next, I would like to share with you. So the green leasing program, the pilot program of a renewable energy certificate transaction for multiple users in single electricity account number. In Taiwan, many companies try to acquire green energy, especially foreign companies and the financial industry as well, because they would want to achieve their ESG goals. So they need to purchase green energy. But they are perhaps a tenant in a particular floor in a building. And so so they don't actually have an account number. So for 101, in Taipei 101, there is a company who is a subsidiary company of L'Oreal, and they are required to use 100% green energy. So L'Oreal Taiwan has that need, but they do not have an account number. So in Q4 of 2020, we actually give these tenants account numbers. So Taipei 101, the building is the account holder, but all the tenants, because they do not have account numbers, so Taipei 101 would purchase on their behalf, and so they would need to give us the information about exactly how they allocate the electricity. They might have a private meter, so the total power used divided by the floor areas is their public consumption. Minus, first of all, you have to deduct the usage of each of the tenants. So the landlord, basically, they would need to sign the contract with Taipower, because Taipower would only recognize the building itself, not the tenants. And so they were actually able to purchase green power from Taipower building, from Taipower, and then it was actually the implementation began in 2020. So we start seeing more cases like this. For example, at Yuanta Securities and also Bank, for their buildings in Taipei and Taichung, they also start taking the same method to purchase green power. And they've actually been able to complete the transaction. And so this year, we start seeing new ways of doing things. We see some of the landlords, for example, the property owners like Taipei 101 or Cathay Life. So before, it was the landlord who purchased on behalf of the tenants. But then they realized that among the tenants, most of them have the need to acquire green power. So they are thinking maybe the landlord can actually buy green power for all the tenants. So before, the landlord were more passive. They were informed about the need of their tenants. However, in this case, they became more proactive. They started to approach Taipower for green power for all their tenants. So if this model continues to develop, and in the future, you will get, when you rent a house, don't only do you get the Wi-Fi, the furniture that comes with it, and also green power. So you don't have to worry about getting green power on your own. So this is something new this year. That is the green leasing, the 2.0. So in the past, it was the tenant who signed the contract, whereas in the plan 2.0, the acquirer is the landlord, and so the landlord would actually sign the contract, and then it would allocate proportionately based on the requirement of the tenants. So this is how it's different from 1.0. So before, the person who signed the contract is the tenant. Now it's signed by the landlord. And say, if there is excess of power, or it could actually be transferred to the landlord. Just so that you can better understand this program, so we give you an example here. For example, if there are 4 tenants in one building, A, B, and C, A, B, C, and D, if they all want to do green leasing, if they if their requirement is about 100,000 units a year. So be it 1.0 or 2.0, it's actually settled on a yearly basis. So you can actually just buy the power for that 1 year, and then you can allocate it among yourself on a different month. Say, for example, the total amount they bought is 200,000, but the requirements are 400,000. So it would actually just be allocated proportionally, but then that's not necessarily a good way. So for this program, one of the tenants, well, some of the tenants, they can become RE100. And for example, user A has a special requirement. They need to be RE100 certified. And they could be a RE100 overseas entity. And so they need to also be RE100 compliant. So they could have the priority to obtain the green power. And so the landlord would actually have to talk to tenants A, B, C, and D. So, A actually got the 100,000 units that they require. So they become RE100 compliant, whereas B is not able to attend. So tenant B just got what they need. And then tenants C and D, they are willing to cooperate. So they got less green power because more was given to A. So, but does that mean they can actually pay a lower price for the green power? Yes. Well, so basically, there will be different prices charged for different tenants. So this is a new business model, and so it's an on-demand system because some people they absolutely have to use that amount of green power, so they might pay a little more, whereas the rest of the power can be distributed among the rest of the users. As to the result, we see that Cathay United Life, they have signed a contract for 4 buildings in September, and then more buildings, more properties are actually on the way. They are talking to us for that. So we believe that by next year, more commercial office buildings will be using green energy. So next, I will talk about the market for renewable energy. So in order to help the corporates to buy green energy, so we have a market now, and it carries the function of investigation, matchmaking, and also implementation. And we will investigate the demand, and we'll also actively match. And there is a QR code. You can actually log into the website using the QR code. And we actually had a market in the previous quarter, and then this quarter we'll also be doing a market. So we have a Taoyuan office actually located in Hsinchu because Taoyuan falls under the jurisdiction of the Hsinchu office. And if you're interested, you can actually sign up for the market. We will provide matchmaking, and there will also be panel discussions. We will actually bring the user and suppliers so that they can have matchmaking. And then for special cases, and if say someone is willing to offer a higher price, and then we can actually do some special matchmaking service for those who are willing to bid higher. And then once the contract is signed, we can actually help them to carry out the admin procedure case by case, and say maybe there's a transfer agreement or cancellation. So we will provide them to get the certificate that they need. So this is something we work together with the Bureau of Energy, and we'll meet regularly to review the results. So besides the renewable energy market, we also have online event. So in the future, the matchmaking will be done online, and for anyone who's interested in carrying out their transaction, and it's you can fill in the information, and it will then contact the interested party, will be like the matchmaker, and then will facilitate the matches. And then, so that is the market. And then for SMEs, we also have a project for the SMEs that is the matchmaking service for solar PV sites of public or state-owned enterprises. So we understand that for the SMEs, it's not so easy for them to get all the green power they needed. So we've actually looked at the situation, and then we come up with a solution so that in June and July, and for the state-owned companies, state-owned enterprises, and they have actually been able to acquire, well, they will be able to release the property, and 30% of that will be used for green electricity. So Thai Sugar and also Bureau of Industrial Development, they are releasing part of the land for the operators, so that the SMEs can actually they have the priority to purchase this green electricity. So we'll offer them the price of 4.3 NT per unit, and they can go to the bidding platform to bid. And so we have this bidding platform for them to bid for the power. So when they buy the green power, there is actually a limit. So the limit is actually 30% of their total consumption the previous year, just so that more SMEs can get a chance to purchase green power, but at a reasonable price, no premium. But the quota is limited. So like I said, 30% of their total usage the year prior to that. And so they can use this bidding platform and a matchmaking platform to find the amount of green power that they need. So, and because this is for the SME, and so it's very clearly indicated in the regulation if they have a capital size under 100 million or staff number below 200, so they can be recognized as SME. In the originally they have to pay a security deposit. However, for the SMEs, it's waived, so they don't need to pay security deposit. And then it can be extended twice, because in the negotiation process, it might take a longer time. And so we allow them to extend and also to negotiate their rights. And that's it for my presentation. Actually, there are many developers here, especially offshore wind developers. And so for the transaction of the green power, when the power is generated, we do have a task force that work on these issues, including, say, maybe group orders, and then also flexible allocation of power. And then this week we also had a meeting about such issue. And if you're interested, we can find a time to discuss that. And thank you very much. That's all for my presentation today. Okay, thank you very much, Mr. Huang, Director Huang. And the SMEs, you please feel free to reach out to Director Huang.
发展谈中小
And next, we'll be talking about Power Up SE's race to go green with offshore wind energy. The speaker is Lucas Lin, Chairman of Swancore Renewable Energy. Chairman Lin is the project director of Formosa One Wind Power Company. This is the most offshore wind farm in Taiwan. Now let's welcome Chairman Lin. Ladies and gentlemen, from the venue as well as online, the previous speaker talked about the problem of green electricity selling in Taiwan, and then the MOEA just held the first meeting to address that issue. And for SMEs, we hear from previous speakers talking about the development of solar PV in Taiwan. And for my part, so how should I advance my slide? So this is the outline of my presentation. First of all, I will talk about my company, Swancore Renewable Energy. So for the past, 10 years, we have a lot of, development. And in the morning's opening ceremony, Chairman Huang of Taitra talked about what President Obama said, that, we are the first generation to feel the impact of climate change. And also we are the very last generation to be able to take action to combat climate change. If we fail to take any action, then our next generation will have no way to turn things around. So I would like to introduce my company SRE to you first, because 10 years ago when we started to engage in offshore wind power, people had a lot of questions toward us. And then actually the first demonstration wind farm was launched more than 10 years ago. And then today, we're talking about that this government's policy is a 30-year-old policy. And then we are now targeting 2050. So I would like to first talk about the history of my company. And now, next, I want to talk about the electricity generated by offshore wind farm. Because from Formosa 128 megawatts, and we can see for the latest project, the generation will be 500 megawatts. So that means for every farm, we need to generate about 2 billion megawatt hour of electricity. So I want to see if there's any gap existing between the demand side and the supply side. And then next, I want to talk about the possible solutions to the challenges that we are facing. So first, on the introduction of my company SRE, in 2012, the government started to promote an offshore wind farm project. So that was 10 years ago. When we talk about net zero, people are wondering whether it is possible because this is a 30-year long plan. But just because this is a 30-year long plan, so we shouldn't, evaluate the success of the project by the technology level that we are having right now. Now we are developing new technology. We're also introducing new framework. And then we have to really take action now so that we can make an impact in 10 or 20 years. So when I started to engage in offshore wind farm in 2012, I always felt that I was doing something for the next generation. But after a few years, I realized that's actually wrong. What I'm doing is for the current generation. Because RE100 started to require the supply chain to work with them. So more than 10 years ago, I worked in the electronic industry. So I have a lot of, old friends in electronic companies, and then they call me to ask me if I'm able to sell green power to them, because it's important for them to be able to procure green power to maintain their sustainability, credit or certificate. And also I have a friend who called me and asked for green power of 700 million kilowatt hours. And he is in plastic injection business. And his clients include, McDonald's and Starbucks. So it's important for him to be able to secure green energy. So we can see there is a great demand out there. And then there is also a chemical company which wants to buy 1.2 billion green kilowatt hours of green power, because they are a supplier of Tesla. So we can see really there is a great demand there. So in 2012, we started to take on the first demonstration project. And then it's been, 10 years. And then we spent 7 precious years to be able to reap some results. And then we can see Formosa 1 is a project which requires more than 20 billion investment. So we can see for Formosa 1, it will actually require 60 billion new Taiwan dollars. But with this kind of investment, you are not able to make profits for the first 7 to 8 years. So you can imagine this is actually a very difficult project. So you can see that is really, the background of my company. And we spent 7 years in this project, but we are not able to generate profits. And in 2018, the government started the second phase selection. And because of our experience in Formosa 1, we are rated number 1. And now we're constructing Formosa 2. In September this year, we also launched 2 wind farms of about 2 gigawatt. So we can see there is a great demand, and also there's a great supply. But how come companies out there are not able to source green electricity? So that is a problem that we need to address. How come it takes so long to develop a wind farm? Because you need to, follow local regulations. You need to select proper sites, and then also you need to pass the environmental impact assessment. So, at the forefront, developers need to tackle all these challenges. And after you get the approval from the government, you need to be able to get finance from banks. And you need to invest, a lot of money, at the forefront. You need to get all the contracts ready. You need to get your, project financing. So what I'm saying here is that as a wind farm operator, how come we're not able to supply you with enough green electricity? Because project finance is really a challenge for operators like us. Because for this investment, for these banks, they are providing a syndicated loan of 20 years long. So they may have doubts as to whether we're able to complete our project. So when we started commercial operation, are we able to sell our electricity to customers? Are we able to repay our loan? So that is a concern from the banks. And this is our portfolio. You can see a trend like this in Taiwan, but actually not just in Taiwan. So when I started to engage in this business in 2012, and then when people feel that, I'm either a liar or a fool, it's like, they feel that I'm like throwing my money into the ocean. But from our past record, you can see that we are working closely with the government. And for Formosa 2 is 376 megawatt. We also have projects of Formosa 4 and 5. So in Taiwan, we have about 2.5 gigawatt. I also have 4 wind farms in Japan, including fixed and floating wind farms. And last week in Korea, I met with a lot of Korean developers or operators. I think that, we're able to, transfer our expertise to other countries. So I just shared with you about our experience as a offshore wind farm operator. So during the process of development, what are our concerns? I've been saying that the development of an offshore wind farm, is technology-based, but still in essence, risk management is very important in this kind of project. Because it requires a very, very long time to be able to, make profits. So when I evaluate my costs and my risks, I will first think about how to avoid risks to save the cost. So what are the problems that are existing in the trading platform? So an offshore wind farm is a project of risk aversion and the financial arrangement. So we require a lot of financing from the banks. Just like what I told you, wind offshore wind farms in Taiwan, we have the technology ready. Because all the technology come from, oil and the gas industry. So we are able to build the wind turbines at ocean of different levels of depth, and it's important for us to carry out our project on time and then on budget. So there are a lot of limitations out there. So we have to get a 20-year long project financing. It's very different from conventional project financing, which is about only 7 years long. So for the banks, when they provide financing, the first, they are concerned about whether you have the capability to finish the project, and second, they're even more concerned about your cash flow. So you need to have international credit rating to be able to get finance from the banks. So that is really the biggest challenge for us. So if we are not able to get triple B plus rating, in that case, it's difficult for me to get money from the banks. So I really require the MOEA to help us to address the issue of bankability. And then the second issue is residual electricity. So we know that renewable energy has very small, carbon footprint. And then because the wind is out there, so we can always get the source of electricity. But, it also depends on the climate, the weather. So maybe there are some gaps between the supply side and the demand side. So coming back to the topic of the Energy Taiwan exhibition, we really need to rely on energy storage system to stabilize our grid, whether it's battery-based storage or V2G-based storage. I drive my EV for 1 hour a day. And for the rest 23 hours, you can use that to store energy. And we have to think about, we can utilize future technology to address the issue. Because, the government has already, set up targets, milestones for 2030 or 2040. So in 2040, fuel cars will be banned totally. And everybody will have a EV, which is a storage system. So you will have a vehicle to grid system. And we need to have a large pool to address the gap between the demand side and the supply side. So for 500 megawatts, we need to generate 2 billion kilowatt hours of electricity. So we can take care of a few users. And what about the residual electricity? That causes a lot of pressure on the operators. So that has a lot to do with bankability. And for the third part, as for corporate PPA market, in the past, there was no collaboration between the supply side and demand side. So I talked a lot. I talk about companies which wanted to purchase green energy, and if we want to nail a deal of power purchase agreement, which is also acceptable by both companies, we know that this will take a lot of time. Well, there is a company in Taiwan which purchase a lot of green electricity, so they have a pretty good framework out there. However, if you look at tier 2 or if you look at the electronic industry, we can see the CPPA market is still immature. And for the last part, well, I can give an example that if you fail to pay your electricity bill, and then Taipower will still supply you with electricity next month, because they will take a record of your usage once every month. However, if my client doesn't pay me for 1 month, and for me it's not acceptable because I won't be able to repay my banks. So we talk about the importance of smart meters, because with smart meters, I can see whether a customer pays me or not. And then if this person fails to pay, then I will stop my supply immediately. And now I want to talk about the potential solutions. For scenario 1, based on the existing system, here we need a big underwriter. So well, some when we talk about, we need to have companies with international credit rating, and in terms of the procurement of green electricity, we need to work with companies with good international credit rating, so that the banks can be rest assured that we can repay them. And for the major renewable energy users, which belong to the government, and then we can see these users can be very good customers. And also, when it comes to companies with good international credit rating, we can see banks are qualified, because some banks talk to me about this issue. So let's look at the price difference here. Whether this kind of business model is lucrative enough to attract other banks. So if you can buy solar power at 5.5 new Taiwan dollars. I know that for offshore wind, it's priced at $4, and for this so-called T company, they can purchase at, for example, 3 new Taiwan dollars per kilowatt hour. So we can see there are price differences there. So so we can see that you can expect to see 70% of price differences. So that means that is that is actually that's profit for you as an underwriter. So we have to think about the first willing contract. For the pricing strategy at Taipower, we can see that between the supply side and the demand side, with the current calculation model, there are gaps out there. So for operators and banks, they cannot guarantee their future cash flow. So that will create a problem for our project financing. And like I told you, Taipower calculate your power usage once a month. And for us, we need to get real-time information. So in terms of willing, we need to have a system that responds quicker. And we also need to have a bankable market. And in Japan, in Europe, there are two models. And the Japanese model is like what Director Huang mentioned. It's a, T-reg model. So all the power is pulled together and distributed by the government. So you can use a renewable energy certificates to make a purchase. So we'll have a centralized pool. So you can use certificates to purchase green electricity. So that is the trading model. And the other mechanism is from EU. There is an unbundled REC. So they have a centralized trading market. So this centralized trading market can be utilized for the supply side and the demand side. So maybe the Bureau of Energy, the MOEA, can be the regulator of this centralized pool. So I think that works as a very good model. So today I talk about the background of my company, the development for the past 10 years, and also I talk about the potential solutions. We need to think about the technologies that may emerge in 10 or 20 years. And what we're doing today is not for the next generation. It is for us. And also offshore wind farm operators, we have the technology in place, but it's difficult for us to get project financing. Thus, we require the assistance from the government. We also need financial institutions with good international credit rating to help us. So with that, I'm closing my presentation. Thank you.
Next, we'll move on to the final presentation, and we'll talk about green energy procurement practice, future business opportunities.
Future business opportunities。那我们要邀请到的讲者呢是瑞能创意影响力办公室的陈彦阳副总。那瑞能创意的 GoGoRo 是致力于创新这个科技产品的设计，还有生产、销售跟服务，当然还有绿能生活的一些 solutions。让我们现在。
So now I would like to welcome the VP of Impact Office at GoGoRo, Mr. Yan Chen. Distinguished guests, good afternoon. It is indeed my pleasure to share with you this very interesting topic today. I'm sure you all know GoGoRo quite well, and the first thing you think of a GoGoRo is probably a scooter. And so what do we have to do with green energy? Actually, we've been saying this many times. We are not just a scooter company. What we do is we can provide sustainable energy solution to build a cleaner, smarter city. So in today's presentation, many people mentioned that the renewable energy is not just cleaner, but it's also smarter. So being a solution provider, what kind of role do we play in building such an ecosystem? So we understand that by 2040 or 2030, there is a ban to sell fuel vehicles. And so, as you know, there are many different EVs, for example, Tesla, and also a lot of traditional car makers. They're also transitioning toward EV by 2025. So when we create the solution for GoGoRo, there are very important trends that is, first of all, how do we enhance the efficiency of energy, and then to reduce pollution, and then to centralize the pollutions, and also to create a more sustainable effect. So this is Tesla. I'm sure you've all seen the car. So when you go home, or like the previous mentioned, you can actually just plug into the charging device. But in most of the Asian Pacific countries, we see this is what dominates the street, the scooters. So can we make these electric scooters, can we charge them when they are parked? So this is at Qingyi University, the parking lot. So how do you build a charging device in a place where there are so many scooters? So that's why we offer the solution, which is a swap and go. It takes only 6 seconds to get it done, so that you can get your power supply just like that. So I'm sure there are Gogoro users here. When you run out of fuel, when you drive a traditional car, you go to the fuel station. Now you go to a battery station. We offer, what we do is a game changer. So with V2G, and we offer this swap station so that we can actually interact with the grid. So at Gogoro, when we talked about our values, so with the swap stations, we can actually generate power and we can give it back to the grid. And we talked about IoT and also the Internet of Vehicles. And we are a mobile solution, and so we offer the smart scooter. And then we also, because it takes battery, we don't use a charging pile, but we use a swap station to supply power. And so that is our ecosystem. And we can own and share. And so you own the scooter, but you rent the battery from us. So the vehicle is owned and the battery is shared. So unlike Tesla or other EV solutions, when you purchase the vehicles, you own everything, including the battery. And then if you need to charge the car, you would have to wait for a little bit because I don't have the charging device at home. I have to go to the charging station. So for us, we want to simplify the power solution. That's why we came up with the idea of the battery swap. So how do we make the energy smarter? This is what we are trying to address. So with Gogoro, we offer 4 different solutions. First, we have a smart scooter, and which allows people to travel with. And then we have the battery swap station, which is Gogoro network. And so this is where people can charge, this is the infrastructure. And then we have a powered by a Gogoro network. We with Yamaha, TGO, Hongjiateng. These are our partners, and we hope that with the infrastructure, more scooter brand can actually participate. And then we do go share as well. And we encourage people to buy their scooter. However, in the major cities in Taiwan, we have the shared scooters, which we call Go Share. And when Gogoro was first rolled out, we were debating whether we should do charging or battery swapping. In 2015, we launched our first scooter, and the charging solution was 35% of the market. Whereas last year, actually all the scooters, 96.8%, they use battery swap. So we created this very important model that everybody uses battery swap. And so it's something actually you see very importantly in Southeast Asia and also Taiwan. In Taiwan, we have now 2,415 swap stations, GO stations. And we have so many stations compared to the gas stations. How does that compare? So we compare the number of stations of gas station and a battery station. So by mid-year this year, and we have in Taipei outnumbered fuel stations by 2.32 times and 1.53 times in New Taipei City. So when you have such a good network of GO stations, yeah, basically you don't need the gas stations anymore. And next, where are they located? For these battery swap stations, many of them actually are in places where you go every day, but it's so small. It doesn't have to take up so much space as the gas station. Say, for example, a lot of the grocery stores, a lot of these supermarkets, and also the gas stations, they come, we will put a little battery station there. And for the storage equipment, by integrating that solution, not only can we offer battery swap, but also store power. So the more applications can be added. So far in Taiwan, there are more than 1 million smart batteries circulating in the network. Some are currently in the station, some are inside of the scooters. Because there are 2 batteries for each vehicle, so there will be, and then we have more than 0.5 vehicles running around in Taiwan, plus backup ones. And then total capacity of these circulating batteries is 1.5 gigawatt hours, so which could supply the total usage of Taipei for 48 minutes. So if you just take 10% of that, and it can actually create a lot of values for the grid. It can balance the usage of the grid, and then a number of exchanges, or the number of swaps, and has achieved 344 million times. And so the stability is 99.9%. So this is actually a system that stood the test of time and also the customer use. And then how many kilos of carbon have we saved? It's 571.4 plus million tons of carbon oxide. So how do we maximize the batteries? So we are looking at the life cycle. So we want to create smart mobility, smart energy. So we need to allow the users to travel on the street so they can power the scooter, and the batteries have its life cycle. Once it's been charged and discharged hundreds and thousands of times, and the capacity or the physical limit and the chemical limit would actually put a strain on the battery life. So it's for that we are thinking, when the battery can no longer be used for the scooters, what can we do with it? So that's the backup store battery that we're talking about. So it's been 7 years because we are in service, so that some of the batteries are now about to be retired. So for these batteries, we could use that for power storage or maybe other uses. And number 3, and for the goal to ban fuel cars by 2035 and 2040, and we will need to produce more batteries, and the batteries will hit its lifespan and will be obliterated. So we could do urban mining, because while you own the vehicle and you share the battery, so actually we own these batteries, so we can manage these batteries regarding the full life cycle. So from cradle to cradle. So we can actually create a circular economy just like that. So right now we are talking to Taiwan and to do a 2-way charging and discharging service. And very importantly, we can help to create demand response for the grid in Taiwan, because we have a capacity of 1.5 gigawatt hours. So if we can actually do a little demand response in peak hour, it can help to stabilize the grid. So this is something we are working together with Taiwan, and we could also find other applications. For example, the parking piles by the streets, and we can actually put our battery in it so that you don't have to use wire to connect to these piles. So they can be connected wirelessly. And we are also looking at how the electric scooters they can have zero emission on the street. However, the electricity that is generated, there is still emission. So what we're doing is that, so if we can replace the scooters with a Gogoro, we can reduce a lot of pollution. However, 33% of the pollution comes from power generation. So even though we're not talking about the RE100 certificate, but we are taking a lot of actions. So we can increase the proportion of green power so that we can generate a total net zero emission when you use electric scooter like us. But we are not as big as Tesla. However, we are seeing that there is a growing demand for green power, so that this is what we are talking about today. And this is the green power that we purchased this year. It might look like a very small amount for most people. It's just it's like nothing. So we actually has purchased that from Shine Fox, from Sunny Founder. But by the end of the year, we are going to buy more. And being a SME, when they buy green power, there is challenge internally and externally. Even though it's very small, but it's not easy to buy green power. For TSMC, they have an account number for a factory, whereas in Taiwan, we have more than 2,000 stations, the battery stations, and some of those they might have a standalone meter. Some of them have a separate, well, a shared meter. So for us to, when we need to purchase green power, it's actually a huge undertaking. And then we can also use our example to see how green power can actually enter each household. Because, well, it's actually a lot of work to convert, to replace the old equipment with the new. And at this point, we are trying to do more, but if we have to start with the swap station, and we need to streamline the process, otherwise it's would only be available for the large corporates, and then also because it's very expensive, and it's we don't have bargaining power. TSMC, they pay a very little price for that, and then actually, yeah, I think most of the big companies they pay less than we do, and so for right now the proportion is low, and because it's, like I said, it's expensive, and then there is not enough sources, so that at Gogoro we can use batteries, the swap station, to balance the supply and demand. And when you go to the station at 8 or 10 in the morning, and because this is the peak hour, and we would actually make sure that the batteries are fully charged, and also it works as a buffer, and then we can understand the demand and supply. But it's actually very difficult to achieve the balance, because right now we purchase the green power from solar energy, or sometimes the offshore wind farm, but there is just not enough to go around. So for the SME, in order to buy green power, it's not easy, and we understand there is still a long way to go. And there are also the external challenges. There is a very complicated system, the transmission distribution, and also at T-Power, there are many different divisions that are in charge of different things. I mean, sometimes we're not able to find the right person to talk to, and then there is for the big companies, they have a dedicated person to just to handle the factory, but we have the station all over Taiwan and also on the offshore island, so the communication cost is actually very high, and then we don't have a large demand, and it's not easy to find a supplier, and also because we have to pay a higher tariff, and so will be more of a burden for us. And if we have more stations, then that means we would actually have to pay a much bigger sum, and which will also be intimidating. So anyway, so today I would just like to share with you, we are a very special company. We are a green power user, and we want to achieve net zero emission, but also we are a platform for clean energy storage. So when we are moving toward net zero emission, how can we play our part to enable this goal. So in a capitalist world, we need to have everything needs to be profitable so that people are willing to adopt it. So Gogoro plays a very important role here, and we look forward to more discussions with you. As being such a small potato in this business, there's a lot of challenges that we need to overcome. We look forward to our solutions together. Okay, thank you very much, Vice President Chen from Gogoro. And would like to thank all the dear speakers for your great presentation. We'll also like to thank the Ministry of Economic Affairs and the Green Energy Promotion Center, Semi-Energy Group, and also the International Trade Institute and also TITRA. And I would like to thank all the participants who are here and online. There's a QR code. You can actually scan it to fill out the survey for the event today. And we would wrap up our program here. So thank you very much.
那在这边呢，也再次感谢各位的莅临，祝大家有一个愉快的一天，谢谢。